30, we're going the other way, where we're asked to find the antiderivative of some function, in this case g of x. So if I'm looking to find the antiderivative, I might call that capital G. Is the antiderivative of g, in which case I'd be looking for the integral associated with 1 over the absolute x 9x squared minus 1 dx. Alright, so essentially we're looking to fit this to a rule. Alright, so if you refer back to a couple of pages ago, or if you happen to know the rules, you'll see or recognize that the one that has the absolute value in it is the secant, or the arc secant rule, or arc cosecant if it's negated. Alright, so that's kind of what we're up against here. So the arc secant rule, I'll just kind of jot it here, that we'd be interested in would be u prime over absolute u square root, for equality square root, u squared minus 1 du. Alright. So that is going to give us the arc secant, or secant to the negative 1 of u plus c. Alright, because basically I'm taking the derivative rule and just rewriting it so that it's a rule for integration. Alright, so what we need to do is somehow get this to fit that. Well, the first thing I notice is that the u squared appears to have become a 9x squared. If I can just figure out what the value of u would be, that would make that 9x squared into a u squared, I think I'll be in at least a good place to start. Alright, so let's let 9x squared be equal to u squared, which would make u equal to 3x. So du dx would be equal to 3. Right? So du is equal to 3 dx. Alright, so it looks like, alright, I got something going on here. We're missing a 3 on the bottom because the rule is the absolute u times the square root of u squared minus 1. Alright, so I get the u squared minus 1, but in order for this to work, this would need to be a 3, or at least a 3x. Alright, so what I can do actually is what I just did, and that is introduce a 3. Alright, but if I introduce a 3 on the bottom, I'm going to have to introduce it on the top also. Alright, so multiply 3, 3. I can clean this up a little bit and make it 3 over the absolute 3x square root of 9x squared minus 1 dx. And so we'd actually be in pretty good shape now, alright, because I can make my substitutions pretty easily. Alright, so that 3 can multiply into the absolute value because it's a constant multiple. The x is the one that we're concerned about being either positive or negative. Alright, so yeah, we're in pretty good shape here because I can now, and I'll use my highlighter again, swap out the 3x for a du. I can swap out, I'll use the pink here, the 9x squared for a u squared, and I can swap out the 3x for a u. So everything would be in terms of u. So I'd have 3 dx being replaced with, again, a du, absolute u, over, there we go, u squared minus 1. All right, so we're looking pretty good here. So yeah, now it's inverse secant of u plus c, and off to the races. All right. With u being 3x. And that's all she wrote for that one. All right? I mean, you can check it. You can do a quick double check. All right? You're plugging it into the derivative rule, and you'll be in good shape there. Oh, you know what? I just noticed something in my rule. Apologies. There should be an x. Well, there's two schools of thought on this. I'll actually show you a little more elaborate explanation real quick. So that u prime is really du dx. I don't want to just make a change and not explain why, all right? Especially since I even confused myself. So if we put a du here, that wouldn't make sense because we'd have a du times a du, which would give you du squared, all right? So we don't want that, all right? So what we would actually want here is a dx, because 1 over dx times dx would cancel out and leave you with just a du. All right, so the rule is either this, well, actually, what you have up here is a variation of the rule as well. So I'll throw that in there. But the final variation is actually the one we used, which would be du over all that stuff on the bottom. All right. So I apologize for that snafu, but you can see here, it's not an excuse, more like just a reason. Like they're so similar. So I just wish I picked up on it a little bit earlier so I didn't have to explain it at the end of the video. All right. Well, anyway, we'll pick it up in the next example, because the rule here is going to be inverse tangent related, because you can see here there's no radical and there's a plus sign in the bottom, which is very similar to the tangent rule. All right, so let's see if I can get this right from the word go. All right, so the rule that we're familiar with is, I'll write it with the prime first this time. U prime over 1 plus u squared. All right, now that's going to be a dx. So you have that. Another variation of that would be du dx with everything else the same. And the final variation would be du over the 1 plus u squared, which I think is the one that we should be aiming for. All right, either way, I'll put some equal signs in here so it looks at least somewhat correct. Inverse tangent of u plus c. All right, so that's what. So this is what we're trying to make it fit to. Now, what some people do, and honestly, I mean, I sometimes default to this myself, is they do trial and error. You have a starting point based off observation of the denominator and say, okay, well, that looks like it's an arctangent. All right, so let me just play around with possible values of u, plug it into the inverse tangent, and then take the derivative and see if I end up with a 5 over 25 plus x squared. You can go that route. I go both ways with that concept. All right, so the first thing I'm going to do here, because I would really love this 25 to be a 1, so what I'm going to do is factor out a 25. So 25, and when I divide each of these terms by 25, I get 1 plus 1/25 x squared, and then I'll have that 5 up top, right, which can be simplified. You know, it's just a question of whether it's worth it to do that, but we'll do it. 5 goes into 25 5 times. And then we'll see where we end up, all right? Because I look at this, and I'll put it in integral form now, because again, what I want is capital F. I said find the antiderivative. I want the antiderivative of 1 over 5 parentheses 1 plus 1/25 x squared dx. All right, just looking at my rule, I don't see a coefficient on the bottom. It's just a clean 1 plus u squared. So this 5, I probably don't want that there. All right, so that 5 could be thought of as 5 over 1. Keep, change, flip. 1 divided by 5 over 1 is going to be 1/5, which can now go to the top. Probably could have rewrote it faster, but you see where we're at here, or where I'm at in life. Feel free to fast forward through these moments if you haven't already picked up on that. So I need that 1 over 25 x squared to become a u squared. All right, challenge accepted. And then we'll see if it fits with the rule. So u squared needs to be 1 over 25 x squared, which would make u equal to 1/5 x. All right, with x possibly being positive or negative, so we don't have to worry about the plus or minus. All right, so du dx would be 1/5. Du would be the same as saying 1/5 dx. We can say it that way too. So we've got a variety of possibilities. All right. So just looking at it, and remember, du dx is another way of saying u prime. So I think we're in pretty good shape here, because I can now take the 1/5 dx and replace it with the du, and take the 1 over 25 x squared and replace it with a u squared. So du over 1 plus u squared, that's the inverse tangent rule. So now I just have to swap out the u with a 1/5 x, and there it is. So the next one looks like inverse sine, so I'm going to let u squared be equal to 4x squared, which would make u equal to 2x. Du dx would be equal to 2, making du equal to 2 dx. H is going to be equal to 1 over the square root of 1 minus 4x squared dx. So we have the substitution for the 4x squared. Now, as far as du is concerned, we want to replace a 1 dx rather than a 2 dx, so I'm going to divide both sides by 2. and then make that substitution. So 1/2 du over the square root of 1 minus u squared du. So 1/2 can be factored out. Oh, I have an extra du there for some reason. Du over the square root of 1 minus u squared, which is the arc sine rule, arc sine of u, plus c, or inverse sine, however you like, where u is 2x. So we are looking at h of x being 1/2 arc sine of 2x, close it up, plus c. Involves what appears to be an arc tangent, but we do have that negative, so you can go either way with this one, with an arctan or arc cotangent. Now, just because I originally wasn't going to do this, but let me just throw it in here. The rule for number 7. Kind of felt bad skipping that step. Alright, so the rule that we'd be looking for here is, oh, sorry, I almost wrote the wrong rule. Du over, I'm kind of cutting to the chase though. The antiderivative of du over the square root of 1 minus u squared. Alright, and then for this one, and of course, as we know, that gives you arc sine of u plus c, or inverse sine of u plus c. Alright, so the rule that we'd be looking for here would be du over 1 plus u squared. That would be the inverse tangent, so arctan of u plus c, or inverse tan of u plus c. Now, the alternative here would be that we could choose negative du over 1 plus u squared. And so that would give us arc cotangent of u plus c, or inverse cotangent of u plus c. All right, so we can go that route too because of the presence of the negative. But I had mentioned previously that the most important are the three, the sine, secant, and tangent, because those are the non-cofunctions. The cofunctions are just based off of the functions themselves. So the x squared is kind of like tailor-made for this, but the problem is this needs to be a 1. All right, so the short answer is, well, let's make it a 1. All right, so p of x can be rewritten as -1 over, I'm going to factor out a 2, 1 plus 1/2 x squared. All right, which could then be rewritten as -1/2 over 1 plus 1/2 x squared. Just did a little keep change flip there. You know, this is 2 over 1, -1 divided by the 2 over 1 is really the same as -1 times 1/2. All right, so if I want capital P of x, which for me doesn't look much different than my lowercase p of x, I'm going to integrate this. All right, so I want my u squared to be 1/2 x squared. All right, so this is going to be a little on the messy side, but it's okay. All right, let's keep it red. U is equal to 1 over radical 2 x du, well, I'll write it as du dx, is going to be 1 over radical 2, which in turn gives us du equals 1 over radical 2 dx. You could write it as radical 2 over 2 if you want, but you know, it's that old rule of like, you can't have a radical on the bottom of the fraction. And You know, the follow-up is, says who? Says my algebra teacher. Okay, well, they just wanted you to learn how to rationalize. And there's nothing wrong with having a radical in the bottom of a fraction. So here we are having radicals in the bottom of fractions. All right, and that's fine. But if you're really uncomfortable, rationalize and call it a day. All right. So if only that was a negative 1 over radical 2 on top. Unfortunately, it is a negative 1 over 2. All right. So the bottom's good. That's something anyway. So the integral of 1 plus u squared, well, we're going to have to do some algebraic manipulation to get the negative 1/2 dx to be swap outable with the 1 over radical 2 dx. All right. Well, it's not really going to be too crazy, because what we can do here is solve this for dx. So radical 2 du would be equal to dx, and then make that our substitution. Alright, so we can't swap out the whole thing, but we could swap out some of it. So we're going to have that negative 1/2. Instead of having the dx, I'm going to have a radical 2 du. Alright, since I'm only looking for negative, I'll go with the cotangent just to keep things fun and interesting here. So I only need the negative du up top, you know, as per the rule. So I'm going to pull out of the integral a radical, I almost pulled out the negative, radical 2 over 2, the antiderivative of du, negative du, over 1 plus u squared, which is the arc cotangent of u plus c, and we know that u is 1 over rad 2 x. So radical 2 over 2 arc cotangent of 1 over radical 2 x plus c would be our antiderivative. Let's make that look more u-like. All right, and so there it is.